Well, good evening, class. This is lesson 4.4 on simplifying fractions, but there's also some extras, some things that we left out of the 4.3 video that you invariably saw when you were doing some practice problems in class. But I just want to kind of wrap up some loose ends, and so let's dig right in, and let's first back up and review a little bit of greatest common factor, GCF review. As you will recall, we do have three main methods for finding the GCF. So think about what those are in your head. You get more out of this if you think really hard while you're paying attention to these videos. So the three methods are to list out all the factors and look for the biggest one in both lists. We've got the division ladder method, and then the last method is to do prime factorization. Okay, and so we've gone through all of these methods, and for each of those methods, there are things you really want to remember. Okay, so for listing out all the factors, that's fine if the numbers are small. Okay, if the numbers are small, things like 18 and 24, listing out all the factors is fine. If you have numbers that are three-digit numbers, this can get really difficult and waste a lot of time. So probably not the way you want to go unless the numbers are really small. We talked about division ladders, and division ladders are really our primary method. It's pretty much my favorite. And for GCF, you can do division ladders on 2 numbers, 3 numbers, 4 numbers. It doesn't matter. When you're finding GCF, it's fine. We do need to be a little bit more careful when we're finding LCM and we use the division ladder method. But that's where the anti-Varner method comes in, and we'll talk more about that. And then finally, prime factorization. Prime factorization usually takes a lot more work, but if the numbers are given in prime factorization, then rather than multiply them out and then do a division ladder, then it would be good to make sure that you know the prime factorization method, where you look through the lists of factors and you take out anything that's in both of them. Now, you might think, okay, wait a second, the opening screen said that we're going to talk about the GCF, and what does that have to do with lesson 4.4, which is on simplifying fractions? Well, it turns out that everything that we do when we're finding the greatest common factor, in terms of finding common factors, is exactly what we're looking for to reduce fractions. So that's what it has to do with simplified fractions. Before we get to that, though, I do want to talk one more thing about GCF, and that's GCF with variables as well. All of those same methods that we just talked about, listing out factors, division ladders, and prime factorization are fine, but they're not just for numbers. We can also find the GCF of things that have variables. So suppose we have, for instance, 24 x squared y cubed z, and we also have 30 x y squared z to the third. Well, by the same token, we can find the GCF. I'm going to do this with a division ladder. So the same thing that we do with the numbers, where we look for things that we can take out, we can do the same thing with variables. So in this case, I can see that 6 goes into 24 and 30, but they also both have an x. They also both have y's. In fact, they both have at least 2 y's, and they both have a z. And I can divide all of that stuff out. So if I take a 6 out of 24, I get 4. If I take an x out of x squared, I'm left with 1x. If I take y squared out of y cubed, I'm still left with 1y, and the z is taken away. On the other number, if I take 6 out of 30, I get 5. If I take x away from x, well, x divided by x is just 1. The y squared divided by y squared is also just 1. And z cubed divided by z would be z squared. All right, now, you don't have to take all of this stuff out at once either. You could have taken out the number first, then take out the x, then take out the y's, then take out the z's, and then you would just multiply down this column. Looking down this column at this point, I do believe that we have nothing else in common, and so we're going to stop there, and so the GCF is 6x y squared z. Okay, sorry, I had to pause the video there for a second, so let me pick back up here. So now what we're going to do is we're going to apply greatest common factor towards simplifying fractions. Okay, so let's go ahead and move forward here. All right, so now let's simplify fractions. All right, so anytime we have a fraction that is not in simplest form, something like 12 over 20, Okay, what do we do to simplify this fraction, guys? Oh, and by the way, I have guests now. Ben and Jack have joined me to help finish up the video, so thanks, guys. Jack, what should I look for in 12 and 20 to reduce this?
To figure out which number could go into them, which would be 2.
Right, I can take a 2 out of both.
Or 4.
And you could actually show the work by showing, and this is what I want you to do a little divide by 2, and so if you divide by 2, you get 6, and you divide 20 by 2, you get 10. Now, Jack, you are right. You actually noticed that you could have divided by 4, which means you can take out another 2, so let's do it again. And what do we get now?
3/5.
3/5. Now, if I had not continued on with what Jack had initially told me, I could have done right from here to here and right from here to here by, like, he noticed that you could have actually divided by 4, and he's exactly right. So, and that's quicker, right? You take it on one step. Now, what's the difference between taking out a 2 and then a 2 or taking out a 4? The 4 is what, Ben? If you look at 12 and 20, tie this back into what we were just talking about. We were just talking about greatest common factor, right? So the way that Jack initially said to do it, he said take out a 2 and then take out another 2, and that works, right? That's kind of like what you do on a division ladder. You take out a little bit, you see if there's anything else, you take it out. If you know the greatest common factor, which, by the way, 2 times 2 equals 4, right?
Yes.
So if you find the greatest common factor, and it came to Jack just a little bit later, if you take that out, you immediately reduce all the way down to simplest form in one step. So that's how greatest common factors figure in with simplified fractions. So either way, the method we use to find greatest common factor, especially when we're doing division ladder, is basically the same way as reducing fractions one step at a time. So there's a tie-in right there. We basically do the same thing to reduce a fraction as we do when we do a division ladder. Okay? But if I already have done the division ladder, or I've done the GCF some other way, if I take out the GCF at the top and bottom, I immediately reduce the fraction to simplest form. So let's do a harder one. Let's take another fraction. Let's take 100, okay, and let's divide it by, how about 100, how about 275? Okay, so what is a common factor that comes out of 100 and 275?
25.
5.
Oh, that's a good one. Now 5, okay, here we go. Here's another example. All right.
It ends in a
So I agree with Jack. Both numbers end in zeros or 5s, so 5 comes out. Okay, and so 5 is a common factor. However, Ben noticed that actually, hold on a second, let me think money. A quarter goes into $1 4 times, and a quarter goes into $2.75, a total of 11 times. If I take out a quarter, hold on, let me back up for a second. If I take out a quarter, that didn't work. If I take out a quarter, 100 divided by 25 is 4. And like we just said, 275 divided by 25. Think about how many quarters go into that. 4 quarters make $1. So then 4 more quarters make another $1. So that's 2. And then 3 quarters make 75. So no, 4 and 3 is just 11. So we get 4 over 11. And 4 over 11 is reduced. Now let's back up for a second. If you didn't see that 25 was the GCF, Jack said take out 5, didn't he?
Yeah.
Divide by 5. So let's divide by 5, and what do we get? The top becomes 20, and if I divide 275 by 5, 5 goes into 27 5 times. It's going to be 50-something. We carry a little 2. 5 goes into 25, 5, so we get 20 over 55, but then again they end in 0 and 5. So now take out another 5, and guess what? We end up with exactly the same thing. So whether you do it in steps like Jack did, or you see the GCF and do it in one step, we will eventually reduce down to something that we can't reduce anymore. Now let me show you something really neat, guys. Let's take these exact same 2 numbers. If I was doing a division ladder on them, look at what we do. Let's take out 5 like Jack did, and sure enough we get 20 and we get 55. Take out another 5, and sure enough we get 4 and we get 11. So it's almost exactly the same process
For all the ways.
to find GCF as it is to reduce the fraction. So whether you find the GCF and then take it out, or whether you just reduce one fraction at a time, what really, if you think of this, if you turn your head and look at this going across here, let's change it to yellow. If you go across here, that's basically just like going down here, right? You can think of these fractions. This is 100 divided by 275. This is 20 divided by 55, and this is 4 divided by 11. So, yep. So that's what GCF, that's how 4, 3 and 4, 4 go together. Now, one last thing. We can do the exact same thing with variables as well. All right, so now let's reduce a fraction where we have variables. So let's take a fraction like 24 x squared y and divide it by 8xy. So again, one step at a time, let's reduce this. Now there's another way we can show our reducing. Instead of all those arrows, what I can do is I can reduce like this. So clearly 24 and 8 have a common factor.
Yeah.
What can you take out?
8.
8. Take out 8. 8 divided by 8 is 1, and 24 divided by 8 is 3. And that actually was the GCF. Okay? Now we could have taken out a 2, and then we would have got 4 and 12. When we realized they're both even, we could have taken out another 2, and we would have got 2 and 6. They're still even. Take out another 2, and we get 1 and 3. Gets you to the same place, but that would be 3 steps.
Can you take out a y in it?
Now, good job. You can also simplify the variables. Both the top and bottom have y, and y divided by y is 1, and on the top we get 1. And what about x's? Do they both have an x?
Yes.
Now, the x is going to be a little bit different. The x, yes, we can take out an x. On the bottom, x divided by x is also 1. Now, this is going to be easy on the bottom. 1 times 1 times 1, I can do that in my sleep. It's going to be 1. On the top, though, what's x squared divided by x? Well, x squared means x times x. If you take one of those x's and divide it back away, you end up with just an x, 1x, not x squared. So the top is 3x, the bottom is 1. And so in this case, this reduces down to just the whole, well, not the whole number, but there's not really even going to be a fraction. It's just 3x.
Oh, I thought you couldn't divide by a number if there was a variable in it.
Yep, you can absolutely do that. So what we're doing is we're going to simplify these fractions. So let's do one more like this. So let's do 2mn, and let's divide it by 6m. All right, so again, let's do the same thing we just did. What cancels in the number part, Ben? What goes into 2 and 6?
2.
2 goes in, and you get 1
1/3.
and 3. And then what about the m's? We have an m on the top and an m on the bottom, so they're going to cancel out.
2 and 1.
They're both going to be 1s, correct? And then the n, there's only one n, it's on the top, so it's going to stay there.
Yeah.
So 1 times 1 times n is n on the top, and 3 times 1 on the bottom is just 3, so we get n over 3. And that is how we simplify. So again, what we're doing here is almost exactly the same as finding the greatest common factor, except now we're actually taking it out and we're putting the remainders down. Okay, that's pretty much it. Okay, so tomorrow we will practice these. So the final slide today, I don't know, I always look for pictures that my girls have downloaded on my iPad, and for whatever reason, I think they're doing George O'Keeffe paintings right now, and so they had downloads. Yeah, so zoom in on a rose. So, you know, it's probably a good thing to remember, because I like to put weird pictures in the daily quiz, because that's kind of an easy thing to remember. So, let's see. Quick recap for the daily quiz. We've got Jack and Ben from 7th grade helped do the video. We've got a rose on the last slide. Let's see, we have tie-ins between greatest common factor and simplifying fractions. We've simplified fractions with just numbers and with variables. We've used division ladders. I think all of that stuff is fair game for the quiz. So, all right, so there's a good quick recap. Enjoy the rest of your weekend, and we will see you in class when we go over this. All right, take care. Say goodbye, guys.
Bye.
Bye.